So in multiple regression model, there will be more than one explanatory variable, more than one
Sir.
independent variable, Yes.
স্যার লাস্টে যে ম্যাথগুলো অ্যাসাইন করেছিলেন ওখানে একটু কনফিউশন আছে একটা ইকুয়েশনে। স্যার আমরা যে এরর বের করি যে ইআই সামেশন অফ ইআই স্কয়ার ইকুয়াল টু সামেশন অফ ওয়াই আই স্কয়ার, আমার কোশ্চেনটা হচ্ছে এখানে ওয়াই আইটা কি ক্যাপিটাল ওয়াই আই নাকি স্মল ওয়াই আই?
এটা হচ্ছে স্মল ওয়াই আই।
স্যার স্মল ওয়াই আই হলে তাহলে কি এটা ওয়াই আই মাইনাস ওয়াই আই হেড হোল স্কয়ার এরকম হবে?
এক্স্যাক্টলি, ওয়াই আই মাইনাস ওয়াই আই হেড হোল স্কয়ার।
স্যার যখন আমরা এইভাবে ম্যাথটা করতে যাচ্ছি কেন যেটা মিলতেছে না, মানে বি1টা নেগেটিভ চলে আসে, মানে স্ট্যান্ডার্ড এরর নেগেটিভ চলে আসে একটাতে।
হ্যাঁ, এটার কারণ হচ্ছে আমি বলেছিলাম যে বি1টা নেগেটিভ আসবে যে যদি আপনি এরকম হয় যে আচ্ছা, লেট মি শেয়ার মাই স্ক্রিন। So I think all of you can see my screen, okay? So here you're actually estimating the sum of EI square, okay? So I told you to estimate this by this, EI into EI, okay? And then first one EI, this EI, it means YI minus YI hat. Sorry, Y minus YI hat, okay? So this is actually capital Y. YI minus Y hat means your capital Y. So when you are giving the value B1 minus B2 xi, so this one now has been multiplied with this, so it becomes EI sum of EI into YI minus B1 into sum of EI minus B2 into sum of EI xi. So this has become 0 because the summation of the EI is 0, and summation of the EI into xi, that means the multiplication of the explanatory variable and your error term. If you take this summation, it would be also equal to 0. So that's why this whole portion has become 0, okay? And then you have EI equal to EI into YI. This is only you have. So where you are actually going to multiply them, this EI means again YI minus YI. In here, this would be B2 into xi, okay? This YI hat means B2 into xi, because I told you in the earlier class when we are measuring the R square. So in the graphical representation, you have your B1 started from here, which is actually the measuring the Y hat equal to B1 plus B2 xi. And you have your Y bar value here, which is the mean value of the dependent variable. And if you have the Y bar here, if you are calculating Y bar, this will remain fixed or constant for the whole groups of X or whole groups of your variable. For example, if you are going to measure this, your Y hat value, I show this here. So this one is your B1. And here is your Y bar. Okay, so I shown you that if your actual Y value is here, this is your Y bar value, okay? And on this line, on this line, this dot is your y hat value. Okay, so yi minus y bar, if you calculate the difference from the actual values to the mean values, this yi minus y bar is your small yi. Okay, and this actual y, from this actual y, if you calculate this difference, this whole difference is known as yi minus y bar. This difference is known as small yi. So capital yi minus y bar, this is known as a small yi. So when actually you are multiplying this in this equation, when you are multiplying yi with yi, this becomes yi square. But I told you that this small yi is the value from the actual values of the yi minus the y bar value. This is the total variation, which is the difference between the actual y values to the mean y values. Okay, so this total variation has been covered by two ways. One way was, let me show you with another color. One way was yi minus y hat values, and another way is, which is not explained or unexplained portion, this one, yi hat minus y bar. Okay, so up to this, I think it's already known to you. We have discussed it in the last class.
Yes,
I
sir.
told you that B1 has been already included in the y bar. এই যে B1 টা আছে এটা কিন্তু y bar এর মধ্যে আছে, because B1 is less than y bar, so the value of B1 has been already included in the y bar. So here in y hat value I have not included B1, because in the y hat value, y hat is the portion value which is actually covered by y hat minus y bar. This portion, this portion is your y hat minus y bar value. Okay, this portion, from this portion y hat minus y bar value, this is the explained portion. Okay, this is the explained portion, and yi minus y hat bar, this is the unexplained portion followed by ei. Okay, so here small y, you have yi minus y bar, which is equals to your explained portion followed by y bar, y hat minus y bar, and plus your unexplained portion followed by yi minus y hat. This is the unexplained portion, second portion. So when you are actually multiplying this here, sum of yi is square, that is okay. This yi and yi becomes yi square, but there is no b1, because b1 has been already included in the y bar, and we have let this small y, so this one becomes a small y hat, and this one become your ei. And after that, when you are actually squaring them, so squaring and take the summation in both sides, so this becomes yi square, this becomes yi hat, small yi hat square, plus this becomes square. This small yi hat square has been replaced with only b2 square. b2x2 square, because this portion is known as explained portion. This explained portion has been explained with the impact of your independent variable x2 or independent variable x. So that is why when I am replacing here y hat equal to b2xi, you can see that y hat has been only replaced with b2x2. b2x2 means your independent variable along with its slope coefficient. So when I am replacing y hat with b2xi, so it is multiplying with this, so which becomes actually b2 sum of xi yi. Now you are just going to calculate the summation of the small yi square minus b2 value, which is the slope coefficient value calculated from your data, and summation of your xi into yi. This is actually your small xi, and this is your small yi. So when you have multiplied them, this small xi yi means, more specifically, it means capital xi minus x bar into capital yi minus y bar. This means sum of xi into yi. তো আপনি যখন এটাকে ফাইনালি আপনি যখন সাম অফ ই স্কয়ার বের করবেন এটা হবে এই ফর্মুলাতে। এখন দেখেন আপনি বুঝতে পারছেন কিনা।
জি স্যার, বুঝতে পেরেছি।
তাহলে আপনার এইটা হচ্ছে সাম অফ স্মল ওয়াই স্কয়ার, এটাকে আবার ভাঙতে হবে। এটাকে ভাঙলে হবে হচ্ছে এই মাইনাস আপনার বি2 আছে, তার সাথে মাল্টিপ্লাই হবে হচ্ছে সাম অফ xi মাইনাস x বার ইন্টু yi minus y bar. এই টোটালটার মাল্টিপ্লিকেশন হ্যাজ বিন কনসিডার্ড এজ সামেশন। ওকে, সাম অফ xi minus x bar ইন্টু yi minus y bar। এইটা মাল্টিপ্লাই হবে b2 এর সাথে এবং দ্যাট there is a minus sign in front of it and here summation of the capital yi minus y bar whole square। এইটা হচ্ছে আপনার ফাইনাল ফর্মুলা। এরপরে ক্যালকুলেট করলে আশা করি এটা নেগেটিভ আসবে না, কারণ আমরা যখন ক্যালকুলেশনটা আপনি করেছেন হয়তো সামনে এখানে বি1 ছিল। আমি এটা গত ক্লাসে বলেছিলাম যে বি1 শুড নট বি কনসিডার্ড হেয়ার বিকজ বি1 হ্যাজ বিন অলরেডি কনসিডার্ড ইন দ্য ওয়াই বার। এখানে যে ওয়াইটা দেখতে পাচ্ছেন সাম অফ ওয়াই আই স্কোয়ার, দিস ইজ ইউর স্মল ওয়াই আই। স্মল ওয়াই আই মিনস ইউর ক্যাপিটাল ওয়াই আই মাইনাস ওয়াই বার হোল স্কোয়ার, মাইনাস হচ্ছে বি2 ইন্টু সামেশন অফ দ্য স্মল এক্স আই ইন্টু স্মল ওয়াই আই। তো এখানে স্মল এক্স আই মিনস হচ্ছে ক্যাপিটাল এক্স আই মাইনাস এক্স বার, স্মল ওয়াই আই মিনস হচ্ছে ক্যাপিটাল ওয়াই আই মাইনাস ওয়াই বার। তো আপনার টেবিলে যখন ডেটা সেটটা প্রিপেয়ার করবেন এই ফরম্যাটে এনে ইউ ক্যান ক্যালকুলেট দ্য ভ্যালু অফ ইউর সাম অফ ইআই স্কোয়ার। এরপর আপনি ইউ স্কোয়ারের ভ্যালু ক্যালকুলেট করতে পারবেন।
থ্যাংক ইউ স্যার।
ওকে,
ইয়েস স্যার।
okay, so any more query regarding the earlier problems?
স্যার এখানে হচ্ছে ই নাম্বার কোশ্চেন যেটা ছিল স্যার 7.12 যেটা, ওটা ই নাম্বার কোশ্চেন স্যার অ্যাকচুয়ালি কি জানতে চাইছে স্যার এটা বুঝতে পারছি
7.12 E number.
জি স্যার।
The natural rate of capacity utilization is defined as the rate at which y is 0. Okay. What is the rate for the period under the study? Natural এটা কিসের ছিল? To study the relationship between capacity utilization in manufacturing in the inflation in states, and we obtained the data shown in the table. Okay, fine. Table থেকে ডেটাগুলো নিন and for inflation rate and x is your capacity utilization rate in manufacturing. Okay, the natural rate of capacity utilization is defined as the rate at which y is 0. What is
এখানে কি y hat এর ভ্যালুটা 0 ধরে আর
what is this rate for the period under the study? আচ্ছা, এটা হচ্ছে আপনার y যদি এখানে আপনার ওরা বলছে যে y is your inflation rate, আবার বলছে which y at which y is 0. ওকে, ন্যাচারাল রেট অফ ক্যাপাসিটি ইউটিলাইজেশন দিয়ে তারা এটা হচ্ছে এক্স কে মিন করছে। তো ন্যাচারাল রেট অফ ক্যাপাসিটি ইউটিলাইজেশন বলছে ইজ ডিফাইন্ড এট দ্য অ্যাজ দ্য রেট অ্যাট হুইচ ওয়াই ইজ 0। তো ওয়াই যখন 0 হচ্ছে দ্যাট মিনস দেয়ার ইজ নো ইম্প্যাক্ট অফ ইউর ইন্ডিপেন্ডেন্ট ভেরিয়েবল, ক্যাপাসিটি ইউটিলাইজেশনের কোনো ইম্প্যাক্ট নাই কিন্তু। ওকে, সো ইন দ্যাট কেস ইউর ওয়াই ইজ ইকুয়াল টু অনলি ওকে। সো হোয়াট ইজ দ্য রেট ফর দ্য পিরিয়ড আন্ডার দ্য স্টাডি? এখন আপনার এই রেটটা জানতে যাচ্ছে যে B1 এর natural rate of capacity utilization is defined. So just 1 second একটু দেখে নিই প্রথম থেকে। আচ্ছা, inflation measured by the GDP deflator. আচ্ছা, এটা আমি একটু পরে আপনাকে এক্সপ্লেন করছি, ওকে? একটু থিওরিটা দেখে তারপর এক্সপ্লেন করি, কারণ ক্যাপাসিটি ইউটিলাইজেশনটা যদি সে জিরো করে, মানে ইনফ্লেশন ক্যান নেভার বি জিরো, ইনফ্লেশন রেট অ্যাজ পার দ্য ইকোনমিক থিওরি, ইনফ্লেশন রেট ক্যান নেভার বি জিরো, ওকে? সো ইনফ্লেশন জিরো থাকাটা মানে হচ্ছে ইটস নট গুড ফর দ্য ইকোনমিক গ্রোথ। সো দেয়ার শুড বি ইনফ্লেশন রেট বিটুইন 2 to 5% থাকা উচিত অলওয়েজ। তো ওরা যেটা বলছে, দ্য ন্যাচারাল রেট অফ ক্যাপাসিটি ইউটিলাইজেশনকে ডিফাইন করছে, ইজ ডিফাইন্ড অ্যাজ দ্য রেট অ্যাট হুইচ ওয়াই ইজ জিরো। তো ওয়াই যদি জিরো হয়, তার মানে পুরো ইনফ্লেশন রেটটা যদি জিরো হয়, then there is no money supply, there will be no employment opportunity, and there will be no capacity. এমপ্লয়মেন্ট না থাকলে তো আপনার ইন্ডাস্ট্রি হবে না, ম্যানুফ্যাকচারিং হবে না, তখন ক্যাপাসিটি ইউটিলাইজেশনও থাকবে না। এই জন্য আমি একটু দেখে আপনাকে জানাচ্ছি, ওকে? I will get back to you at the end of the class, ওকে? আর কোনো কোয়েরি আছে এটা ছাড়া? Okay, so we are going to start the class with the next chapter, that is chapter 8, multiple regression, estimation and hypothesis test. So here the main difference is in the earlier two chapters we have only single regression function, where we have only one dependent variable and one independent variable, and we have estimated the value of b1 and b2 from there. And we have also tested their statistical significance, that means whether they are statistically different from zero, considering the test of hypothesis approach. And test of hypothesis can be was done using either interval approach or a level of significance approach. So today we are going to do the same thing. We are going to estimate the parameters of the regression function. We will test their statistical significance, but only difference is this time we are going to deal with the multiple regression function. So in multiple regression function, there will be more than one independent variable. There will be more than one independent variable, and there will be only one dependent variable. Say you have, in the earlier case, you have only one x, that means only one independent variable. Now you will have x2 and x3 being two independent variable, and we will also have a dependent variable followed by y, and this y is your dependent variable, and this x2 and x3 are your independent variable, and that's why it is known as a three variable model. Okay, so in this three variable model or three variable regression function, followed by like yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i. So here your beta 2 and beta 3 are the slope coefficient for the corresponding two independent variables, and your beta 1 is the intercept coefficient for your regression model, and this model is known as PRF without error term. But when you are estimating the error term, that means your stochastic PRF. So in that case, it would be looks like B1 plus B2 x2y plus B3 x3i plus your UI error term. This is known as stochastic PRF. Okay. And as we know that we are not dealing with the population, we are not dealing with all observations of the population, we are only dealing with the sample. So we will measure, or we will estimate the parameters of this population regression function beta 1, beta 2, and beta 3, considering a sample. And in sample, we will estimate the beta 1 with a proxy parameter followed by b1. We will estimate beta 2 with a proxy parameter of b2. We will also estimate the beta 3 considering a proxy parameter b3, and we also estimate the error term of ui considering a proxy parameter of ei, which is known as stochastic SRF, sample regression function. Okay. Now the question is, how would we estimate the value of B1, B2, and B3, considering the sample regression function? Okay. So in that case, again, we have to go through the process of ordinary least square method, or OLS method. And in the OLS method, you know that OLS will estimate the value of estimating the value of B1, B2, and B3 in such a way so that the square between the actual value, square deviation between the actual value and the estimated value, followed by yi hat. You know that yi hat means if you are going through this sample regression function, which is inclusive of your error term followed by ei, your yi hat is the portion which is explained, or which is actually fitted by the regression line, or which is explained by your independent variables. So these portions are your explained portion. So when we are considering yi hat, it means the yi hat is your function of the regression line. Yi hat is your function of the regression line. So that is why yi hat belongs to b1 plus b2 x2i plus b3 x3i. This portion is followed by yi hat. So here we are estimating the value of b1, b2, and b3 in such a way so that when we are taking the deviation from the actual y value, estimated y value, yi minus yi hat whole square, it would be minimum. It would be minimum. It would be minimum means, more specifically, yi minus yi hat is followed by ei. So your summation of the ei should be minimum. That means summation of the ei square would be minimum. So when you are going through the minimization and maximization of the function, you know that your given function must be partially differentiated with respect to the following parameters. Now you have three unknown parameters. One is b1, b2, and b3. For these three unknown parameters, you will require at least three equations to solve for the value of b1, b2, and b3. So similarly here, you will have to go through three partial differentiation process, so that in every case, you are going to measure the respective parameter value with a consideration of summation of a square would be minimum. Summation of your square deviation between the actual value and estimated value would be minimum. So in that case, for example, for the first one, only for B1, I will show you for the B1, and then B2 and B3 will be also automatically calculated considering the same approach. So for estimating B1, differentiate sum of EI square with respect to B1. So we'll have to differentiate sum of EI square with respect to B1 and put it equal to 0. So more specifically, it means you will have to differentiate your sum of EI square to B1 and put it equal to 0. And then from this portion, you will get an equation which is yi minus again yi hat whole square is equal to 0, and b1 minus b2 x2i minus b3 x3i whole square is equal to 0. And then you have 2 in front of the in the exponent, so that will come in front of them, and it will become y minus b1 minus b2 x2i minus b3 x3i and you will have to differentiate the insider portion. Insider portion, and then put it equal to 0. And after that, you have differentiated the inside function with respect to b1. So there is the other values or other parameters value will become constant, and constant's differentiation is 0. So d by db1, that means differentiation of the y will become 0. Differentiation of the b1 will be only the differentiation, because you are differentiating the inside function with respect to b1. So it will become b1 to the power 1 minus 1, because b1 has become variable now because you are differentiating it, and the other values b2 and b3, all of them will become 0 because they have become constant. And this is only this is happening only because of the partial differentiation, because you are differentiating the whole function with respect to only one variable, and that is b1 here. And after that, the rest of the calculation is as same that you have done in the earlier chapters. So this will become minus 1, and this 2 will be cross multiplied with 0, so it has been 0 also. And sum of yi minus b1 minus b2 x2i minus b3 x3i into minus 1. So minus 1 has been eliminated once you have multiplied the both side with the minus 1. So we will have only summation of yi minus b, summation of the b1 minus b2 into summation of the x2i minus b3 into summation of the x3i is equal to 0. So we can write down it sum of yi equal to sum of b1 minus b2 sum, sorry, plus b2 sum of x2i plus b3 sum of x3i. And then you can also divide the left hand side and right hand side with the summation. So summation of the y be divided by n. Summation of the b1, it is actually means nb1, so it has been also divided by n. b2 sum of x2i can be also divided by n. b3 sum of x3i can be also divided by n. So you will have actually y bar here, capital Y bar, and here you have only b1, because this will become sum of b1 is equal to nb1. So n and n has been crossed. You have only b1 here, and b2 x bar plus b3 x3 bar. Okay. So this is your equation number 1. And similarly, when you have differentiated this one with respect to b2, you will get another equation. So when you are differentiating it with respect to b2, you will get, so differentiating sum of ei square with respect to b2 and put it equal to 0. So it would become d by db2 sum of ei square is equal to 0. So in that case, you are actually differentiating sum of ei square with respect to b2. b2 is your variable now, and all other two parameters b1 and b3 has become now constant, and constant's differentiation will be 0 in that case. So up to this, you just have to replace the value of your sum of ei square, which is yi minus yi hat whole square. And then the rest of the procedure is almost similar that we have done in the earlier case of b1. So it would be minus b1 minus b2 x2I minus b3 x3I whole square is equal to 0. 2 into sum of yi minus b1 minus b2 x2I minus b3 x3I to the power 2 to the power 2 minus 1, and you have to differentiate the inside function, which is sum of yi minus b1 b2 x2I minus b3 x3I, and this whole one is equal to 0. And the rest portion is 2 has been crossed with 0, so you have differentiating with respect to b2 in the inside function. So you have yi, b1 and b3 x3I, these all becomes constant, and for this your constants differentiation is 0. So 0 for the yi, 0 for the b1, and here you are differentiating it with respect to b2. So b2 to the power 1 minus 1, and this one has become x2i. x2i is your constant here, and b3 x3 whole portion is constant, so constant differentiation is 0. So what actually you have here is yi minus b1 minus b2 x2I minus b3 x3I into minus to the power, sorry, minus into x2I, because b to the power 1 minus 1, it has become b to the power 0. And if b to the power 0 has here, then equal to 1. So b to the power 0 equal to 1. So 1 has been multiplied with minus x2I. So it remains with minus x2I. And then just multiply it with your left side function. So actually now you have summation has been multiplied with this inside function, minus x2I will be multiplied with this. Minus x2I has become plus x2I if you multiply both sides with the minus 1. So it would be actually required to be written another line that it will become only x2I if you multiply both sides with the minus 1. Okay. So after that, you have summation of the yi x2I minus b1 into summation of the x2I minus b2 into summation of the x2I whole square minus b3 into summation of the x3I, which is equal to 0. So you have sum of yi x2I is equal to b1 sum of x2I plus b2 sum of x2I whole square plus b3 sum of x2I into x3I. This is your equation number 2. Okay, so you have developed 2 equations. You have to develop another 1 equation to solve for 3 unknowns. You have actually the first equation developed b1 plus b2 x2 bar plus b3 x3 bar. Okay, and similarly in the same approach, you have also developed the second equation, and in the same approach you can also develop the third equation, because you have 3 equations to solve for 3 unknowns, b1, b2 and b3. So this is the approach of the linear equation, approach of the ordinary least square method. Okay, so we need 3 equations to solve for b1, b2 and b3. Anyway, so for the third equation, I'm not going to do the same thing again. The third equation will be using the same, just write, you have to write down that differentiating sum of ei square again with respect to which one? Now we are going to differentiate the error square with respect to b3, okay, and put it equal to 0. So in that case, it would be d by b3 into sum of yi square is equal to 0. And then you just use the same approach that we have done in the development of equation number 2. And after that, your equation number 3 will be sum of yi x 3i is equal to b1 into sum of x3i plus b2 into sum of x2i x3i plus b3 into sum of x3i square. That would be your equation number 3. Okay, and considering these 3 equations, now the question is how can we estimate the value of b1, b2 and b3? So if you have the text in your hand, would you please move on to page number 215. 215. গিয়েছেন সবাই?
Yes, sir.
Okay, equation number 8.17, 8.17, 8.18 and 8.19. These are the 3 equations I have just developed, E1, E2 and E3. দেখেন মিল পাচ্ছেন কিনা? ঠিক আছে? ইকুয়েশন গুলো দেখতে পাচ্ছেন? 3টা ইকুয়েশন?
Yes, sir.
Okay, so the first one, 8.17, that is my equation number 1, which is here, this one. এই ইকুয়েশনটাকে মিন করছে 8.17, y bar equal to b1 plus b2 x2y plus b3 x3 bar. Okay, this is my equation number 1. They have also developed, they have also given here. And then from the second equation, what I have developed, this one, that is their equation number 8.18. Same আছে? 2x2 square plus b3 x2 x3. Okay, then the third equation, differentiating the ei square, sum of ei square with respect to b3 and put it equal to 0. Our third equation has been found, sum of yi x3i equal to b1 sum of x3i plus b2 sum of x2 x3i plus b3 into sum of x3i square. Okay, these are the 3 equations from which they have estimated the value of b1, b2 and b3. 3টা ইকুয়েশন আছে, 3টা থেকে আমাদের 3টা আননোন বের করতে হবে, b1, b2 and b3. Okay, so they have already given you the format that b1 is equals to y bar minus b2 x2 bar minus b3 x3 bar. Okay, and b2 is equal to, after the algebraic, they have some manipulated with the algebraic function. They have some they have done some algebraic manipulation to know b2 and b3. তো আমাদের যখন 3টা ইকুয়েশন দেওয়া থাকে, ধরেন এরকম করে যদি দেওয়া থাকে যে 9x plus 3y plus 2z is equals to 15. Another one is 3x plus 2y plus z is equals to 10. And x plus 2y plus 3z is equals to 25. So from these 3 equations, we can estimate the value of x, y, and z. So similarly, from the 3 equations we have just developed, they have also estimated the value of b1, b2, and b3. So their b1 is equals to y bar minus b2 x2 bar minus b3 x3 bar. Just interchange the first equation's value. Interchange the first equation's left hand side and right hand side. They have found this. And after that, they have estimated the value of b2 with summation of the here small yit into x2t. T is for the time. Okay, sometimes your data set will be given with the time series data. Sometimes your data set will be given with the cross-sectional data. Sometimes it would be followed by the panel data. Okay, so here when you are taking that subscription is t for any variable, it means this is the time series data. Only the variables observations are given against or given corresponding to a specific time. A specific time series. So that's why there is a subscription T has been taken. So T means the data deals with the time series data only. It is not dealing with the cross-sectional data. It is not dealing with the panel data. So more specifically, your data series has been given by this, that this is your time. this is your y, this is your x1, this is your x2. So here is your observations are given, here is your samples are given, and your time is 2002 by 2020. So these 20 years observations are given with the respective dependent variable y and independent variable of x1 and x2. So in that case, your subscription will be t. Okay, that is showing the time series data. And then summation of the x3t square minus summation of yt into x3t and summation of x2t and x3 divided by summation of x2t square into summation of x3t square minus summation of x2t into some x3t whole square. Okay, here everything is a small x and a small y. Small x and a small y means capital X minus x bar and capital Y minus y bar. So I'd like to write down it here that small x2t, I have written down it small x2t or small x3t. So a small x2t, it means capital X2t minus capital X2 bar, and small x3t means capital X3t minus capital X3 bar. That means from every actual observation of x2 and x3 variable, you are deducting their mean value. And that is actually led by small x2t or small x3t. And then the value of B3 will be also calculated with summation of the yt into x3t, because in the earlier case you have used x2t, and here it would be summation of the x2t square minus summation of yt into x2t into summation of x2t x3t, and in the denominator portion this will remain same. Remain same because if you take summation of the x3t square and then multiply summation of x2t square, it will remain same because they are in the multiplicative form. Okay, so you can directly calculate the value of B1, B2, and B3 from the given set of observation or given set of data. And then you can also calculate their standard errors, standard error of B1, standard error of B2, and standard error of B3, because these standard errors will be required to know the statistical significance of those three parameters that you have estimated considering the ordinary least square method. Because this chapter is focusing the two branches of statistics that we have already done in the earlier two chapters. One was estimation of the parameter, another one was hypothesis test. So once you have estimated the parameter B1, B2, and B3 with these formulas, and then you have to test their statistical significance, whether these three parameters are a good approximate of the population regression function or population regression parameter, because we are actually estimating the proxies of beta 1 followed by B1, proxies of beta 2 followed by B2, and proxies of beta 3 followed by B3. So whether these three parameters, which has been estimated based on the sample observation or sample data, whether these three parameters are a good approximate or are a very much good representative for the population regression function, that is what we are going to test considering the hypothesis testing approach. And this hypothesis test actually will give you the guideline whether the value of the B1, B2, and B3 are statistically different from zero. When we are actually asking about the statistical significance, it means whether the value of B1, B2, and B3 are statistically different from 0 or not. You have to prove it considering some hypothesis. So that is what we are going to do once after we have estimated the parameter value. So in that case, when we are going to test the hypothesis for to know their statistical significance, we have to know their standard errors. We have to know the standard errors of those three parameters, B1, B2, and B3. Because without a standard error, we cannot conduct the t-test or z-test. Okay, so this t-test and z-test will be required to know the statistical significance of those three parameters. And when you are going to do the t-test and z-test, you will definitely require the definitely require the standard errors of those three parameters. ওই তিনটা প্যারামিটারেরই স্ট্যান্ডার্ড এরর জানতে হবে, because in the t-test denominator portion you will have to give the standard error of the parameter, respective parameter for which you are doing the hypothesis test. In the z-test you will have to deploy your standard error of the respective parameter for which you are doing the hypothesis test. So once you have estimated their values of the parameter, you have to know what is their standard error. That is the question. And standard error is required to conduct the hypothesis test to know the statistical significance of those three parameters. Okay. So now we are actually going to solve a problem from our exercise of the text from this chapter, where we will first estimate the parameters, these B1, B2, and B3, and then we will conduct their calculation of the standard error to know their statistical significance considering the hypothesis test. And that is from the page number 239. Page 239, problem number 8.8. So you are given some information. You are given y bar equals to 367.693. You are also given x2 bar equal to 760, and x3 bar equal to 8. You are also given sum of ya square, small ya square is 66,042.269. Then you are also given small x2y square. Okay, here you are given actually I will be given. I has been given when you are considering the cross-sectional data. Okay, you are when you are giving the subscription I with y and x, your respective variable, then you are considering the cross-sectional data. Okay. Anyway, so sum of x2y square is given 84,855.096. And then you are also given sum of x3a square is equal to 280. Sum of yi into x2y is equal to 74,778.346. Sum of yi into x3i is equal to 4,250.9, and sum of x2y, x3i is equal to 4,796. So these are the information you are given, and based on which you are also written that where lowercase letters, as usual, denote the deviation from the sample mean value. So actually, all values are the lowercase value. All y and x are here in the lowercase value. These all are the lowercase value. And these lowercase values actually means small x means you are actually dealing with the x, capital X from the actual values, deviation that deduction or minus with the mean values, and small y values, it means the deviation between the actual values of the y and their mean values. Okay, so this is what they have given you as a clue. And then in number A, requirement number A, you have been asked to estimate the 3 multiple regression coefficients. 3 multiple regression coefficients means you are actually has been asked to, you have been asked to estimate the value of B1, B2, and B3. These are the 3 slope coefficient, or these are the 3 coefficients. B1 is the intercept coefficient, and B2 and B3 are the slope coefficient of your regression model, because your model is followed by yi hat equal to yi equal to B1 plus B2 x2i plus B3 x3i. Okay, plus is your error term. This is your stochastic SRF. And from this SRF, you have been asked to estimate the value of B1, B2, and B3 considering this information. Okay. So you know that your B1 is equals to y bar minus B2 x2 bar minus B3 x3 bar. So from the given 3 equations that we have, from the given 3 formulas for 3 parameters in the left hand side, I have just written here this one. B1 is equal to y bar minus B2 x2 bar minus B3 x3 bar. Okay. And B2 equal to this, B3 equal to this. You have to just replace your information, what you are given in your question here. And then you will get your value of B1, B2, and B3. So similarly, here also, I will just follow this formula here to calculate the value of B1, B2, and B3. So B1 is equal to y bar. So you are given y bar equal to 367.693 minus B2 will be calculated later. X2 bar is given 402.760 minus B3 will be calculated later. X3 bar is equal to 8. That is the information you are given. So once you have get back to the value of B2 and B3, you can calculate the value of B1. So it's very important to calculate B2 and B3 first and then replace their values in the right hand side of the B1. So B2 equal to, as you know, that B2 equal to, the formula is sum of yt into x2t. Here it was t, but now you are dealing with the I means your cross-sectional data. So in every case, you will have to replace 2i or yi. Okay. And then sum of x2i square, x3i square minus sum of yi into x3i, and then sum of x2i and x3i. This is the numerator portion, and then in the denominator portion you have sum of x2i square, sum of x3i square minus sum of x2i into x3i whole square. Okay, that was your formula. Now just replace your value as per the formula. So sum of yi x2i, sum of yi x2i, this is equal to 74,778.346. 74,778.346, and this will be multiplied with sum of x3i square, which is 280 as per the information given, and then sum of yi into x3i is given 4,250.9, which will be multiplied with sum of x2i into 3i. That is sum of x2i into x3i is given 4,796 as per the information. and this is your numerator portion's value, and your denominator portion is sum of x2y square, which is given 84,855.096, and sum of x3y square is given 280 minus sum of x2y into x3y means your 4,796 whole square. Now calculate the value of B2 here from here. ক্যালকুলেট করে বলেন কত এটা।
There's 0.726. There's 0.726.
0.726 এতো?
Yes, sir.
Okay, so after that you can also estimate the value of B3 with sum of yt x3t multiplied with sum of x2, okay, not t, it's I, x2y square minus sum of y I into x2i multiplied with sum of x2i x3i divided by the denominator portion will remain same. Okay, it will be 84,855.096. Okay, just a minute. So just replacing the value, calculate the value of B3 here also. হ্যাঁ করেছেন ক্যালকুলেট? So what's the value of B3?
Sir, 2.736. 2.736.
ওকে, তো উপরে সবগুলা বসিয়েছেন তো, ভ্যালু বসিয়ে, আর নিচেরটা তো যা আছে তাই, মানে B2 তেও যা ছিল B3 তেও তাই আছে।
Yes,
সো
sir.
ডিভাইড করার পরে ইউ হ্যাভ 2.736. ওকে,
Yes, sir.
আচ্ছা। So now your B1 can be calculated now. B1 was just replace it in the earlier one here. Okay, you can calculate B1 now. So it is equal to 367.693 minus B2 value was 0.726 that we have just calculated, and B3 is 2.796. Okay, 736. 2.736 into 8. So what's the value of B1 now?
Sir, 53.4. 53.4.
40. Okay. So you have B1 value, B2 value, and B3 value. All of those values have been already calculated. Now your second requirement is requirement number B, that was calculation of the standard error, maybe estimate their standard errors. So we have been asked to estimate the value of what is the standard error of the B1, standard error of the B2, and standard error of the B3. Okay, what is their value? Calculate করতে বলেছে আপনাকে। So here when you are calculating the standard error of the B1, so it has a derivation. So I would like to request you to move on the page number 215. 215 আসেন। And there you can see at the bottom of the page variance and standard errors of the OLS estimators. দেখতে পাচ্ছেন? Variance
Yes, sir.
Yes, sir.
Yes, sir.
and standard error of OLS estimators. So they have already derived some formula to calculate the variance and standard error of the OLS estimator. So we have also estimated the standard errors of the OLS estimator in the last chapter, in the last chapters. So it was like variance of B1, and then take the square root of the variance, you will get the standard error. So variance of the B1 has been given a formula 1 by n. In the following page, page 216, you can see that the formulas are given directly, which is equal to sum of x2 bar square, and then multiplied with sum of x3i square plus x3 bar square with sum multiplied with sum of x2 square minus 2 into x2 bar x3 bar into x2 sum of x2 and x3i. Okay, this is the numerator portion, and in numerator portion you have already calculated the value of B2 and B3 with the same denominator portion, which is summation of the x2i square sum of x3i square minus sum of x2i x3i whole square. This portion is already known to you. because you have just calculated the value of B2 and B3 where the denominator portion was same. And these would be multiplied with error variance, which is followed by sigma square. Okay, so this sigma square or error variance, more specifically, it is known as the variance of the EI. Okay, error variance or variance of the EI. EI is the error term whose variance has been calculated with the sigma square. We know that from our earlier calculation. First, this information is already known to you. First portion of the variance of B1, 1 by x2 bar, x3 bar, sum of x2 by x3, everything is known to you, but you do not know what is the value of this error variance. How can you calculate the error variance? As our error variance has been calculated based on the sample data, we will put a cap sign on it. And this is our error variance, which has been calculated based on the sample data. And it is equal to sum of EI square, that means residual sum of a square or sum of EI square, divided by n minus k, divided by actually its degrees of freedom. So n means the number of observation you are dealing with. K means the number of K means the number of explanatory variables including the intercept terms. K means the number of explanatory variables including the intercept terms. So actually K means we have lost 3 degrees of freedom here. One is B1, another one is B2, and another one is B3. Because when we are dealing with the summation of the EI square, we will calculate the value of summation of EI square. Well, this EI square means, more specifically, it means summation of the yi minus yi hat whole square. So it means EI square can be calculated once we have known the value of yi hat, and yi hat has been calculated with the value of B1, B2, and B3. So that is why we have lost 3 degrees of freedom while calculating the error variance, and that's why its degrees of freedom followed by k will be 3. And here it would be n minus k, which means the number of observation means n, and k means the number of explanatory variable including the intercept terms. So sum of EI square divided by n means here the total number of observation is 15. 15 is the total number of observation, and k means 3. Why 3? I already told you. Number of explanatory variable including number of slope coefficient including the intercept terms, because I already told you we have lost 3 degrees of freedom, B1, B2, and B3. B2 and B3 are my slope coefficient and B1 is my intercept coefficient. So that's why there will be 3. So it means you can calculate the value of error variance, which is sum of EI square divided by 12. Now, how can you calculate the sum of EI square? Sum of EI square can be calculated if you have the text in your hand from the page number 216. At the bottom of the page, you can see that EI square is given a direct formula. Can you all see? দেখতে পাচ্ছেন সবাই?
Yes, sir.
Okay, sum of y square minus b2 into sum of yi into x2y minus b3 into sum of yi into x3t 3i divided by 12. So here they are using the small y. So again, I would like to explain you why the sum of EI square formula, sum of EI square calculation formula is without B1. Can you all see that there is no presence of B1? B1 কিন্তু নাই এখানে, দেখতে পাচ্ছেন সবাই?
Yes, sir.
Yes, sir.
Yes, sir.
The earlier calculation, in the earlier chapter, I also told you B1 should not be in the calculation of the sum of EI square. এটা থাকা উচিত না, because B1 is already included in, কোথায় আছে B1 টা? B1 is
X bar.
already included in the y bar.
Why?
Sorry, আমি উল্টা বললাম যে y bar has has already included b1, so b1 is inserted with the y bar, y bar এর মধ্যে b1 ঢুকে আছে। তো y বারটা আমরা কোথায় ইউজ করি? y বার আমরা ইউজ করি হচ্ছে when we are calculating the small y সমান হচ্ছে all actual values of the y should be deducted from its mean value y minus y bar। এই y বারের মধ্যেই কিন্তু b1 টা ইনসার্ট করা আছে। So that's why when you are calculating the summation of the ei square, there will be never presence of the b1 এখানে থাকবে না। তো আমি এই ফর্মুলাটা ডেরিভেশনটাই দেখাচ্ছি, দেখেন তাহলে বুঝতে পারবেন যে why sum of ei square equal to this one, how this formula has been developed and why there is no b1 in this formula. So we know that sum of ei square is equal to sum of again yi minus yi hat, eta. So here you know that sum of yi hat means to x2i, আমি কিন্তু আর b1 লিখছি না এখন, দেখতে পাচ্ছেন? Can you all see that I am not writing the b1 here?
Yes, sir.
Yes, sir.
And here is b3 into x3i. Okay, so there is no b1, প্রথম থেকে b1 eliminate করে দিলাম আমি। ওকে, একটু ছোট ভুল হয়েছে আমার, কোথায় ভুলটা করলাম এই যে দেখেন, আমি ইটাকে ভাঙি নেই, এটা ভাঙতে হবে আর কি, ei into ei, এখানে একটা ei আছে আর স্কয়ার হবে না তখন। So sum of ei square can be written as sum of ei into ei, so which is equal to sum of yi minus yi hat into ei। ধরেন ei এখানে একটা ভাঙলাম আর একটা রেখে দিলাম আমি। Okay, so and then you just know that sum of yi minus b2 sum of x2i minus b3 sum of x3i, and you have ei with it. Now multiply it with the whole function. So this portion has become 0. Why? এটার পুরোটা 0 হচ্ছে কেন বলেন তো?
সামেশন ei আর x এগুলো 0 হয়।
সরি, শুনতে পাচ্ছেন না, কি বললেন?
স্যার সামেশন অফ ei ইকুয়াল টু 0 হয়, সামেশন অফ ei x।
হ্যাঁ, ei into x equal to হচ্ছে 0, এটা ছিল আমাদের সেই CLRM এর যে অ্যাজাম্পশন, সেটা মনে আছে যে ক্লাসিক্যাল লিনিয়ার রিগ্রেশন মডেল assumes that summation of the error term, summation of the multiplication of error term and explanatory variable is equal to 0. So if this portion is 0, b2 and b3 has become also, and then you have only sum of yi into ei. So after that, this one is again yi minus yi hat. So y hat means b2 into x2i. Again, I am eliminating the b1 because considering b1 is included in the y bar. And b2 into sum of yi x2i, b3 into sum of yi x3i. আচ্ছা, এইবার এই স্মল ওয়াইটার সমান কি আমরা জানি, y minus y bar whole square. এখানেও স্মল y আছে, স্মল x আছে, সেগুলোকে একইভাবে y minus y bar into x2 minus x2 bar। এখানেও স্মল y আছে, এটাকে আমরা লিখবো y minus y bar, এখানে আমরা লিখবো x3 minus x3 bar। ওকে, এই অংশটাকে আমরা কি বলেছিলাম, in the calculation of the r square we consider this portion sum of yi square as our total sum of a square, TSS। মনে আছে আপনাদের TSS, total sum of a square is equal to ESS plus RSS?
Yes, sir.
ওকে, তো আমরা যদি ধরে নেই ধরে না এটা আমরা জানি যে সাম অফ ইআই স্কোয়ার মানেই হচ্ছে কি আরএসএস, রেসিডুয়াল সাম অফ স্কোয়ার অর সাম অফ ইআই স্কোয়ার, দিজ আর সেম। ওকে, তো এই আরএসএস যেটাকে আমরা বলছি, তো লাস্টে এসে আমি আরএসএস সমান কি পেলাম, সাম অফ স্মল ওয়াই স্কোয়ার মাইনাস দিস পোর্শন, দিস ইজ দ্য এক্সপ্লেইন পোর্শন। তাহলে এটাকে আমরা এখন সাজিয়ে লিখতে পারি যে ওকে ফাইন, this small y a square can be written down as TSS or total sum of a square. তাহলে আমরা এটাকে লিখতে পারি এইভাবে, that RSS is equal to my total sum of a square. If I take minus as a common portion from this, so this would become plus, মাইনাসটা কমন নিলে এই মাইনাস কি হয়ে যাচ্ছে, প্লাস হয়ে যাচ্ছে। Okay, so now you can write down RSS is equals to TSS minus this whole portion is the explained portion, ESS, or error sum of a square. এখন দেখেন তো বুঝতে পারছেন কিনা। এখন আপনি এই ফর্মুলাটার সাথে দেখেন, এই যে RSS যেটা সমান আমরা সাম অফ ইআই স্কোয়ার বলি, এই ফর্মুলাটার সাথেই দেখেন আপনার যে বইয়ে ফর্মুলা দেওয়া আছে সাম অফ ইআই স্কোয়ার, এটা মিলছে কিনা। বইয়ের ইকুয়েশন নাম্বারটা দেখেন 8.31, পেজ নাম্বার 216 এ ইকুয়েশন নাম্বার 8.31 টা দেখেন, ঠিক আছে।
Yes, sir.
Yes, sir.
Yes, sir.
Sum of vi square is equal to sum of small yi square minus b2 into sum of yi x2i and minus b3 into sum of yi into x3i. এই অংশটাকে, so this is your formula of the sum of ei square which you have given in your text, and that is the derivation procedure of sum of ei square. Here is no presence of the b1, so b1 has been already included in the y bar value, and y bar is the mean value which has been given as a deviation from the actual values, and after that we have let it in the small yi or small xi. তো সেই কারণে দেখেন এখানে কিন্তু b1 টা নাই, b1 টা আপনার y bar বা x bar এর মধ্যে অলরেডি ইনক্লুড করা আছে। So anyway, so this is your formula of calculating the sum of ei square. The next portion, this formula can be this, that RSS or sum of ei square is equal to total sum of square, because this total sum of square is followed by only sum of yi square, small yi square, minus, if you take the minus as a common portion, then this portion b2 into sum of yi x2i plus b3 into sum of yi x3i, this portion has become your ESS or explained sum of a square. We know that from our earlier calculation of the r square is equals to ESS divided by what, TSS. এটা আমরা আগের ক্লাসে দেখে আসছিলাম না যে আর স্কয়ার কিভাবে ক্যালকুলেট করে।
Yes, sir.
সো এখান থেকে আমরা আর স্কয়ারটাও ক্যালকুলেট করতে পারবো if we just take ESS divided with the TSS or total sum of a square. Okay, because we know that here TSS is equals to the ESS plus RSS. Okay, এটাই হচ্ছে আমাদের ফাইনাল derivation. So এখান থেকে আমরা r square পরে ক্যালকুলেট করব। So now just I have shown you the derivation here. Now just put down the value in your calculation to calculate the error variance. এখন আপনি আমরা আসলে ছিলাম, we were at the calculation of the error variance এর calculation এ ছিলাম, this one. Once we can calculate this error variance, we'll put down it here in our calculation of the variance of B1, and then we can calculate the standard error of the B1. The error variance calculation will be followed by sum of EI square divided by 12, and sum of EI square is calculated with sum of YA square minus B2 into it, this one. Just replace the value here, then you will get the value. Sum of YA square is given, value কত দেওয়া আছে দেখেন, এই অনুযায়ী ভ্যালুটা বসান। Sum of I square is given 66,042.269, and then minus your B2 has been calculated. B2 valueটা কত আসছিল জানি? B2
Sir,
valueটা
0.72.
0.726. Okay. Point 0.726. And this will be multiplied with sum of yi into x2y, which was 74,778.346. Okay. And then minus your B3 value was, B3 ভ্যালুটা কত ছিল?
2.736.
Sorry, 3 point কত?
2.736.
2.736. And this would be multiplied with sum of yi into x3i, which is 4,250.9. And in the denominator, you have 12. Now calculate the value. So what would be the value of your error variance? Sigma hat square ei. এটার ভ্যালুটা এখন কত আসবে আপনি পেয়ে যাবেন।
Sir, 10.227.
10.227.
7.
So this is your error variance. Now replace it. And এটা কোথায় বসাবো জানি আমরা? Here in the calculation of the variance of B1. The calculation of the variance of B1. We will, in that point, sigma square ei, we will put down the value of 10.227. Okay, that is our error variance. And all other values or all other observation values or calculation will be followed by your information given in the question. Question বাকি গুলা তো সব দেওয়া আছে, যেমন নিচের অংশটা উপর অংশটা, এগুলো সবই আপনার ইনফরমেশন দেওয়া আছে। আশা করি এটা ক্যালকুলেট করতে পারবেন, নাকি এটা দেখাতে হবে ক্যালকুলেশন?
স্যার পারবো।
পারবো স্যার।
পারবো স্যার।
ওকে, তাহলে আমরা এখানে বলে দিই এইটুকু অংশে এখানে হচ্ছে 1 বাই কত 15 প্লাস বাকি উপরে এগুলা বসাবেন, ইনফরমেশন বসিয়ে ক্যালকুলেট করবেন, দেন মাল্টিপ্লাই ইট উইথ 10.227. That is your error variance found. Now once you have calculated this, that would be the value of your variance. Okay, so you have to take its square root to know the standard errors of the B1. B1 এর standard error যদি আপনি জানতে হয়, take the square root of this value. So the standard error of the B1 is the variance, the square root of variance of B1. Okay, then you get the standard error of the B1. So similarly, you can calculate standard error of the B2 and standard error of the B3. এগুলো তো পারবেন আশা করি পরেরগুলা।
Yes sir.
Okay, আমি ফর্মুলা লিখে দিচ্ছি, লেখাই আছে আপনার টেক্সটে, আপনি যদি দেখেন, you are directly given the formulas here in page number 216 পেজে কিন্তু সবগুলা ডিরেক্ট ফর্মুলা দেওয়া আছে, দেখতে পাচ্ছেন সবাই?
Yes sir.
পেয়েছেন?
Yes sir. Yes sir.
So variance of B2 বলা আছে in the numerator portion only is summation of the x3i square divided by the denominator portion will remain same with the variance of B1 calculation, sum of x2i square into sum of x3i square minus sum of x2i into x3i. Okay. And this would be definitely multiplied with whom? এটা কার সাথে মাল্টিপ্লাই করবো জানি আমরা?
error term.
Variance of the error term, okay, not the error term, variance of the error term. And then we can calculate the standard error of the B2 with the square root of variance of B2. এটা calculate করবো আমরা। Variance of B3 will be followed by the same formula, just the change will be in the numerator portion, it would be summation of the x2i whole square, okay? And in the numerator portion will remain same as in the variance of B2 portion. And this would be also multiplied with the error variance. And then we can calculate the standard deviation of the B3 with the square root value of the variance of B3. Okay? তো এটা আপনারা করবেন, আমি আশা করি এইটুকু পারবেন এখন, কারণ সবকিছু তো সেট করে দেওয়া আছে। You can just replace the value from the information given and then you can calculate the respective values of the standard errors of the B1, B2 and B3. Okay. And
Yes,
then in the requirement C from the same problem, requirement number C, obtain R square and R square bar. Okay. Let me first talk about R square. R square means that same small r square, which is the coefficient of determination, okay, which we have already discussed in the earlier class for the last chapter, coefficient of determination, that will actually give you a clue that how much your sample regression function or SRF, or how much your estimated regression function will be approximate or close to the population regression function, how much it will fit very good or very bad, how much it will fit good to your population regression function, okay? কতটুকু ভালো এটা ফিট করলো পপুলেশন রিগ্রেশনের এগেইনস্টে সেটা আমরা জানতে পারি হচ্ছে by observing the coefficient of determination or R square value. So here, how can you calculate the value? So we know that R square is equals to explained sum of a square divided by total sum of a square. So I already gave you a clue that explained sum of a square can be calculated with the calculation procedure of the sum of EI square or RSS. RSS এর ক্যালকুলেশন থেকে কিন্তু আমরা ESS টা পেয়ে যাই। আমি নিচে যখন আপনাদেরকে শো করেছিলাম এই যে এটা, এখান থেকে দেখেন, this portion is your ESS or explained sum of a square. If you divide this portion ESS with your total sum of a square, then you will get your R square value. So your total sum of a square means your small yi square, summation of the small y square is your total sum of a square. And this portion, whole portion, B2 into sum of yi x2y plus B3 into sum of yi into x3i, this whole portion is your ESS or explained sum of a square. So once you just divide ESS with the TSS, then you will get your R square value. Or you can also alternatively calculate your R square value with this one. এটা আমি শো করেছিলাম গত ক্লাসে, তারপরেও বলি। So if you divide TSS, if you take TSS in that cross multiplication side, that means in the right hand side, then ESS plus RSS divided by your TSS. So you can write down 1 equal to ESS by TSS plus RSS by TSS. So we can write down that ESS by TSS is my R square, and this one RSS means sum of EI square divided by TSS means your summation of the YI square. So R square can be also calculated with 1 minus sum of EI square divided by sum of small y square. আমরা এখান থেকে R square টা বের করতে পারি, ঠিক আছে? The same approach, you can also calculate the value of R square with 1 minus sum of EI square divided by sum of small yi square. তো এই ভ্যালুটা আমরা জানি অলরেডি যে sum of EI square কত and sum of yi square is given to us. Sum of EI square ভ্যালুটা কত আসছিল? 10 পয়েন্ট।
ভালো হইছে। খেলা মানে টোকা মিস করতে তুমি ভালো হইছে না এবার নীল কাটাল দিবি ওয়ান ছাড়া
of EI square ভ্যালুটা দেখেন কত
ধুমবিনি মাইরে তো আগে 27 একটা নিয়ে গেলাম এখন আর পানি পাচ্ছি না আমি খেলি পাচ্ছি না সমস্যা লেগে গেছে এই তো
Okay, let me mute some of you are talking, so let me mute you.
আচ্ছা ঠিক আছে না আমি খেতে পারছি না এই চারটা মারো অথবা ওরে মারতে পারো
Okay. So you can also calculate the R square value with sum of EI square. আপনি যেভাবে যান দুইভাবে চাইলেই ক্যালকুলেট করতে পারবেন either you can go through the ESS divided by TSS or you can also go through with the R square calculation with this 1 minus sum of EI square divided by sum of YI square আপনি এইভাবেও চাইলে ক্যালকুলেট করতে পারবেন okay we know that sum of EI square means that you are already given that 1 minus B2 into sum of Y B3 into sum of X3I এভাবেও চাইলে আপনি ক্যালকুলেট করতে পারেন or you can directly just put down this formula মানে দুইটা ফর্মুলা আছে আপনি যে কোনো একটাতে ইউজ করতে পারেন either r square equal to ESS by TSS or r square equal to 1 minus sum of EI square divided by sum of YI square এইটাতে যান if you go through the first equation for r square calculation then ESS is equal to B2 into sum of YI into X2I plus B3 only the explained portion explain sum of a square portion sum of X3I divided by your TSS means your sum of Y square. So just replace the value, then you will get the value of R square from here. So apni B2, B3 value বসান and rest of the values are already given in your question. So এগুলো বসালে you will get the R square value. দেখেন এইটুকু বুঝতে পারছেন কিনা Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, এটা পারবেন ক্যালকুলেট করতে না এটা দেখাবো
স্যার পারবো
হ্যাঁ নিচের অংশটায় বসাবেন হচ্ছে 66,042.269 আর উপরে B2 ভ্যালু জানি কত ছিল আমাদের 0.53 সামথিং বোধহয় কত জানি ছিল B2 ভ্যালু কত ছিল
0.726
into 6 sum of YI into X2Y হচ্ছে 74,778.346 and B3 value কত ছিল
2.736
into sum of YI into X3I. So that was 4,250.9. Okay. So and then you can get the value of R square. It is about R square. There is another requirement you have been asked to calculate. R square bar. So R square bar means adjusted R square. Adjusted R square. Okay, what is actually adjusted R square and how it would be calculated? So there is a direct formula of calculating adjusted R square, but why we will require to calculate adjusted R square? Because you know that only R square, the unadjusted R square, does not use the degrees of freedom in calculation. The degrees of freedom or when we are calculating the R square value, there is no portion, there is no formula that will include the degrees of freedom concept. So what actually we have to require to calculate the adjusted R square is when we are calculating this value, this will give a value which is less than the unadjusted R square. Remember that always your adjusted R square will give a value which is less than unadjusted R square. Okay, less than or at best equal to same. Okay, so adjusted R square will give a value which is less than or at best equal to unadjusted R square. Now, what is actually adjusted R square? Adjusted R square is called adjusted R square because R square has been adjusted with consideration of the degrees of freedom and the number of explanatory variables you have included in your model. You can see that when you have a linear regression model with only two explanatory variables or two independent variables, your R square will give you a specific value. When you have added another independent variable like this, your regression model is y equal to b1 plus b2 x2i plus b3 x3i. Okay, but if you have included another value of b4x4i, another explanatory variable, your R square value, unadjusted R square, which is without bar, unadjusted R square value may be increased. So when you are adding more explanatory variable with your regression model, your R square value will be increased in order to be a good fitted regression line corresponding to or compared to your population regression function. মানে in summary হচ্ছে যে when you are adding more explanatory variables, your R square value will be increased and adjusted R square value will be decreased. I repeat, when you are calculating the adjusted R square value, it has two properties. The first one is when you are adding more explanatory variables in your regression model, your R square value, your only R square value will be increased. And it will be increased in order to show that your regression model is very much good fitted regression line compared to your population regression function. And this R square value has been increased in order to show that these are the explanatory variable which have included in your model. These are the explanatory variable for which your dependent variable yi has been changed, or for which the variation in your dependent variable yi will be followed. Okay, because of these added explanatory variables. And that's why your R square value has been increased. For example, in case of your in case of your three variable model where you have only two explanatory variable, your R square value is found 0.95. When you have added another explanatory variable x4, your R square value may be 0.96. When you have added another explanatory variable, it will be increased to 0.967. Okay, like this. So it means the more you are adding the explanatory variable in your regression model, the more representative this model will be to the population regression function. The more fitted this model will be to the population regression function. And that is why R square value has been increased when you are adding more explanatory variable. That is one kind of that is one kind of fitting of the regression line compared to your population regression function. And alternatively, sorry, not alternatively, and on the other side, in contrast, actually, when you are adding more explanatory variable, the adjusted R square value, when you are adding more explanatory variable, the adjusted R square value by R bar square, this will be decreased. This will be decreased. Now you can ask me, R square has been increased. I have already said that R square has been increased when you are adding more explanatory variable. Why adjusted R square has been decreased when I am adding more explanatory variable? I already told you that adjusted R square considers the calculation of degrees of freedom. Adjusted R square considers the concept of degrees of freedom in calculation of this value. And the value of adjusted R square has been started to be decreased when you are adding more explanatory variable. It is because one kind of penalty. Penalty means you are actually making your regression model more clumsy when you are adding more explanatory variable. আপনি ইচ্ছা মতো 8টা 9টা 10টা 11টা 12টা 13টা করে ভেরিয়েবল অ্যাড করছেন। তো অ্যাড করার কারণে কি হচ্ছে, রিগ্রেশন মডেলটা অনেক বেশি ক্লামজি হচ্ছে, কমপ্লেক্স হচ্ছে, জটিল হচ্ছে। এই কমপ্লেক্স এবং ক্লামজি হওয়ার কারণে adjusted R square value started to be decreased, and it's one kind of penalty as you are adding more explanatory variable in your regression model apart from your relevance. প্রয়োজনের চাইতে আপনি বেশি explanatory variable অ্যাড করা শুরু করছেন, এবং একটা সময় দেখবেন মানে very surprisingly at one point of time when you are adding more and more explanatory variable, at one point of time adjusted R square value, R bar square value will start to be increased. And that is the point. You have to be stop adding more explanatory variable. আমি আবারও বলছি, যখন আপনি শুধু আর স্কোয়ার ভেরিয়েবল ক্যালকুলেট করবেন, আপনি যত বেশি ইন্ডিপেন্ডেন্ট ভেরিয়েবল অর এক্সপ্লেনেটরি ভেরিয়েবল মডেলে অ্যাড করবেন, the more you are adding explanatory variable in your model, the R square value will be increased. Only R square value will be increased. And simultaneously, adjusted R square value will be decreased. মানে আপনি explanatory variable যত বেশি অ্যাড করবেন, R square value increase করতে থাকবে আর adjusted R square valueটা একই সাথে ডিক্রিজ করতে থাকবে। R square value ইনক্রিজ করার কারণ হচ্ছে বেশি রিপ্রেজেন্টেটিভ হচ্ছে, ক্লোজ হচ্ছে টু দ্য পপুলেশন রিগ্রেশন ফাংশন। আর অ্যাডজাস্টেড আর স্কোয়ারটা ডিক্রিজ হওয়ার কারণ হচ্ছে একই সময়ে, because you are adding more explanatory variable in your model that will make the model clumsy, and that is one kind of penalty for which it is going to be decreased. Mathematically এটা ডিক্রিজ হওয়ার কারণ হচ্ছে adjusted R square considers the concept of degrees of freedom, which has not been considered by the R square. R square calculation এ degrees of freedom টা নেওয়া হয় না, কিন্তু adjusted R square calculation এ the formula of adjusted R square is equal to 1 minus unadjusted R square multiplied with n minus 1 divided by n minus k. This n minus 1 is your degrees of freedom. This n minus k is also your degrees of freedom. Okay, these two degrees of freedom in the both numerator and denominator portion have been considered in the calculation of the adjusted R square value. And that is why when you are adding more explanatory variable, the only R square value has been increased, but adjusted R square value will be decreased. Okay, that is the nature. And this is the first property I have just explained you. The second property is, when you are adding more and more explanatory variables in your regression model, at one point of time, surprisingly, you will observe that your adjusted R square value will be started increased. আপনি একটা পয়েন্টে গিয়ে দেখবেন যে adjusted R square value ইনক্রিজ করা শুরু করছে। And when adjusted R square value started to be increased, that is the point you have to stop for adding more explanatory variable. ওইখানে আপনাকে সাথে সাথে থামতে হবে যে I cannot add more explanatory variable. আমার কথা বুঝতে পারছেন যে আমি explanatory variable কতটুকু পর্যন্ত বাড়াতে পারবো? What is my limit? My limit is, unless adjusted R square value started to be increased, I can increase the explanatory variable. I can add more and more explanatory variable unless the adjusted R square value started to be increased. যতক্ষণ পর্যন্ত না adjusted R square value increase করা শুরু করবে, তার আগ পর্যন্ত I am eligible to increase or I am eligible to add more and more explanatory variable. আমি ইচ্ছা মতো explanatory variable add করতে পারবো মডেলে বা increase করতে পারবো। But যখনই adjusted R square value has been started to be increased, that is the point I have to stop for adding more and more explanatory variable. Is that clear to everyone? These two explanation.
Yes, sir. Yes, sir.
Okay, তাহলে আমি যদি কোনো মডেলে আমার 7 বা 8 ভেরিয়েবল থাকে, সেখান থেকে আমি 2টা 3টা বাড়াতে পারবো unless my adjusted R square value started to be increased. Okay, যখনই এটা ইনক্রিজ করবে, then I have to stop for adding another explanatory variable. আর কোন explanatory variable আমি ইনক্রিজ করতে পারবো না বা অ্যাড করতে পারবো না। আচ্ছা, আরেকটা বিষয় হয় অনেক সময়, sometimes we know that R square value will remain between 0 to 1. R square সব সময় 0 থেকে 1 এর মধ্যে ভ্যালুটা থাকে, because this is a square value, it can never be negative. So its minimum value is 0 and maximum value is 1. But adjusted R square value can be negative. Adjusted R square valueটা নেগেটিভ হতে পারে। আমার কথা বুঝতে পারছেন? শুনতে খুব অদ্ভুত লাগতেছে যে adjusted R square, it's a square, how can it become negative? হ্যাঁ, it can become negative when your regression model is completely or very closely inappropriate, completely or very closely inappropriate to your population regression function. ধরেন R square value আসলো 0.09. This is your R-square value, 0.09. Very close to zero. That means it is not representative to the population regression function. My sample regression function on which I have calculated this R-square, my SRF or sample regression function, is not representative or approximate to the population regression function. It is poorly fitted with the population regression function. মানে খুব poorly যখন fit করে ডাটাটা তখন আপনার R-square value অনেক কম আসে। And when this less amount of R-square value has been used to calculate your adjusted R-square value, adjusted R-square calculation also 1 minus R-square into n minus 1 divided by n minus k. That is the format of adjusted R-square calculation. এখানে আপনি R-square সমান 0.09 বসিয়ে দেখেন, you will get an adjusted R-square value negative. আমার কথা বুঝতে পারছেন? And sometimes when your adjusted R-square value has become negative, it means that your fitted regression line or your fitted regression function is poorly approximate to the population regression function. মানে এটা খুব poorly fit করছে, খুবই খারাপ ভাবে fit করেছে, মানে it's not close to the population regression function. It is far away from the population regression function. In that case, it means you have to rethink your model, you have to re-estimate your parameters of the sample regression function. নতুন করে আবার সবকিছু estimate করতে হবে by increasing the sample size or any other option. Okay. তো যখনই আপনার adjusted R-square value has found negative, it's an alarming sign that your whole estimated regression function is badly or very poorly approximate to the population regression function. Is that clear to everyone?
Yes, sir. Yes, sir.
তাহলে আপনারা adjusted R-square value এখান থেকে ক্যালকুলেট করতে পারেন। First you have to calculate the R-square value. এখান থেকে আপনি R-square valueটা ক্যালকুলেট করে নেবেন by replacing the values from your information given, and then from there you can calculate the adjusted R-square value by replacing the information as well as the number of observation, and K means your number of slope coefficient including the intercept term. তার মানে এখানে হচ্ছে 3, তাহলে আমরা এখানে হচ্ছে 1 minus R-square value যেটা আসে এটা ক্যালকুলেট করে বসাবেন। n means 15 minus 1 in the numerator portion and the denominator portion 15 minus 3. Okay. So I hope this up to this portion is clear to everyone.
Yes, sir.
Okay. After that, number D. আজকে আর ব্রেক দিচ্ছি না, আমি একসাথে শেষ করে দিব। ওকে
Okay, sir.
So in number D, you have been asked to estimate the 95% confidence interval for B2, মানে beta 2 and beta 3. দেখতে পাচ্ছেন সবাই? In your question, number D, you have been asked to estimate the 95% confidence interval for beta 2 and beta 3. That means you are actually estimating beta 2 and beta 3 with the proxy of B2 and B3. So for them, when you are constructing the 95% confidence interval, probability of lower value with the t-test value and upper limit value with the 95% confidence limit. And you know that as you are dealing with the total number of observation 15, your degrees of freedom will be 15 minus 3. That means 12. And on the 12, from the table of your t-table, from the t distribution table, for the degrees of freedom 12, your 95% confidence interval. So 5% is the level of significance. So your tabulated value is showing 1.782. So your lower limit value is minus 1.782 and upper limit value is plus 1.782 for 95% confidence interval. And our degrees of freedom is n minus k. So that means 15 minus 3 12
স্যার
12
আমরা টোটাল টেস্ট করছি না
জি হ্যাঁ it is two tail test because you are not asking আমি কি two tailটা দেখছি না নাকি one tail দেখছি এখানে সরি আমি one tail এটা বেশি
2.179 হবে
হ্যাঁ
মনে
সরি এটা হচ্ছে -2.7192 থ্যাংক ইউ আমি আসলে দেখছিলাম হচ্ছে one tail এরটা 5% দিয়ে এটা হচ্ছে two tail এর -2.179 2 plus 2.179 okay because you have not been asked to move in any other direction you have been asked to calculate the 95% confidence interval for beta 2 and beta 3 so by default always go for two tail test okay if there is no clue given so now probability of -2.179 to +2.179 is equal to 0.95 the table t test b2 minus beta 2 divided by standard deviation of the b2 2.179 is equal to 0.95 and then standard deviation of the b2 will be calculated from your earlier part of the calculation এটা তো আপনি আগে ক্যালকুলেট করে আসতে হবে পার্ট বি তে আপনি স্ট্যান্ডার্ড এররস অফ ইউর এস্টিমেটস অর্থাৎ b1 b2 and b3 এর যে স্ট্যান্ডার্ড এরর আছে সেটা আপনি আগে ক্যালকুলেট করবেন and then that calculation will be given here in the denominator portion okay and this will be multiplied with -2.179 standard error of the b2 and this would be also multiplied with here and then from here b2 value আমরা বের করেছিলাম না we have estimated b2 value which is 0.736 something এরকম ছিল না মনে আছে ভুলে গেছেন
0.726
0.726 ওটা এখানে বসাবেন and then deduct it from a 2.179 into standard deviation of the b2 2.179 এটা আবার প্লাস করব b2 এর সাথে so b2 plus 179 with multiplied with standard deviation of the b2 equal to 0.95%. So using the information from your earlier calculation you can get the value of b2 equal to 0.736 and you will also get the value of standard deviation of the b2 and replacing those values you can construct this confidence interval approach you can construct this confidence interval for the beta 2 which is one of the estimator of the population regression function এইটুকু আশা করি এরপরে তো পারবেন বাকিটা আপনারা জাস্ট ভ্যালুটা বসাবেন and once you replace the value you can get the lower limit of the beta 2 and upper limit of the beta 2 lower limit upper limit দুইটাই পেয়ে যাবেন এখানে বুঝতে পারছেন
Yes, sir.
তাহলে আমি জাস্ট ভ্যালুটা বসিয়ে রাখছি 0.736 by 9 মাল্টিপ্লাই করবেন এটার সাথে আর বিটা 2 তো হচ্ছে আপনি যেটা জন্য কনফিডেন্স ইন্টারভাল করছেন 0.736 plus 2.179 0.95 is 95% level of confidence okay so this is how we can construct the confidence interval for beta 2 in the same approach or in the same way we can also construct the confidence interval for the beta 3 ওটা দেখাচ্ছে না পারবেন তো এটা নাকি
স্যার পারবো স্যার
CI for beta 3 okay তো সেটার হচ্ছে লোয়ার লিমিট বসবে কত একই ভ্যালু 2.179 শুধু চেঞ্জ করবেন হচ্ছে এই জায়গায় এখানে 3 হবে b3 minus beta 3 divided by standard error of the beta 3 আর আপার লিমিট হচ্ছে 2.179 বাকিটা হচ্ছে আগের মতোই ক্যালকুলেট করবেন ওকে Okay, so we are almost at the end of this calculation. তো এটা পারবেন, আমি ছেড়ে দিচ্ছি, ঠিক আছে? মানে এটা যদি পারবেন বলেন তাহলে আমি পরেরটায় যাচ্ছি, ইতে। এটা পারবেন না আবার পুরোটা আমাকে এই লাস্ট পর্যন্ত দেখাইতে হবে। B3 এর ভ্যালু আপনি জানেন, 3 পয়েন্ট সামথিং। ওকে, এটা বসাবেন, বসিয়ে প্লাস মাইনাস করে ইউ উইল গেট দ্য লোয়ার এন্ড আপার লিমিট ভ্যালু। Okay, then we are in part E, test the statistical significance of each estimated regression coefficient using level of significance 5%, two-tail test. বলেই দিয়েছি, specifically বলে দিয়েছি, you have to use two-tail test. The statistical significance of each estimated regression coefficient. We have three regression coefficient. One is B1, B2, another one is B3. So for these three regression coefficient, out of them, two are the slope coefficient, and this is the intercept coefficient. Okay, so for these three regression coefficient, you have been asked to estimate whether they are statistically significant or not, individually. Okay. Okay. One thing that you have to understand here, B2 and B3 are the slope coefficient, which is actually related to your explained portion. That means regression portion. And B1 is the intercept portion, which is the B1 is the intercept portion from your regression function or regression model. So when you are actually going to test the hypothesis for these three coefficient, first of all, for beta 1, which is estimated by the proxy of B1, let your null hypothesis B1 is equal to 0. And alternative is beta 1 is not is equal to 0. So that is how you will have to let or assume your hypothesis. One is beta 1 equal to 0, another one is beta 1 not is equal to 0. And then you can go for any approach, either by confidence interval approach or by test of significance approach. If you go through the test of significance approach, then you will have to estimate it with B1 minus null hypothesis value of the beta 1 divided by standard deviation of the B1. So you will get the value of standard deviation of the B1 from the earlier part of the calculation. B1 value is already estimated with the earlier section, minus beta 1 is your null hypothesis value 0. And then you will get the value of the calculated value of the t-test. For hypothesis test, so this is your position of the t on the middle, it is 0. So after that, in here, sorry, say your calculated t value, this calculated t value, if it is found 15.23 or 20. So this is the 15.20. Sorry, not this is the 15, but this is the position at which your level of significance will be started. And this is the position at which level of significance will be started. You are using the two-tail test. In both sides, you have 5% scattered equally, 2.5% in the left-hand side and 2.5% in the right-hand side. So this is the position of the level of significance from which your null hypothesis will be rejected. Okay. So if your calculated t value is 15.20, it will be fallen under the level of significance portion. So you will have to reject the null hypothesis. I don't know what is the value. After calculation, you'll get the value of t. I am just using it hypothetical value. Okay. And your lower limit and upper limit value of the t, as per your confidence interval approach, you already seen in the earlier part of the calculation, that it is minus 2.1. কত ছিল জানি আমাদের tabulated value? minus
179.
Minus 2.179. And here it is plus 2.179. So if your calculated value of t is fallen within the minus 2.179 and plus 2.179, that is your acceptance region. So in that case, you will have to accept your null hypothesis or fail to reject the null hypothesis. But if it is fallen outside of the minus 2.179 or plus 2.179, say here in this case, if our calculated t value is 15.20, so this is fallen under the outside of 2.79 in this significance portion. So here it is 15.20 is fallen under the level of significance portion, so we will reject the null hypothesis. Okay, so that would be our decision. So reject H0. So that is how you can conclude the statistical test or a test of hypothesis to know the statistical significance of each of the estimated regression coefficient B1, B2, and B3, followed by beta1, beta2, and beta3. Okay. সো এইভাবে আপনি স্ট্যাটিস্টিক্যাল টেস্টটা করতে পারবেন টু নো দেয়ার স্ট্যাটিস্টিক্যাল সিগনিফিকেন্স। আমি আবারও বলছি, স্ট্যাটিস্টিক্যাল সিগনিফিকেন্স মিনস, এখানে যে ওয়ার্ডটা ওরা ইউজ করেছে, যে স্ট্যাটিস্টিক্যাল সিগনিফিকেন্স মিনস statistically different from zero. Different from zero. So in our alternative hypothesis H1, we have assumed that beta1 is not is equal to zero. If it is not is equal to zero, then we can conclude that this beta1 or coefficient is statistically different from zero. But if our null hypothesis has been accepted, which is followed by beta1 equal to zero, then we can conclude that statistically this coefficient is not statistically significant, or statistically this coefficient is not significant. Significant তখনই হবে যখন আপনার অল্টারনেটিভ হাইপোথিসিসটা accepted হবে, অর্থাৎ যখন beta1 not is equal to zero হবে। আর যদি beta1 equal to 0, which is given under the null hypothesis, if null hypothesis is accepted, then we can conclude that statistically this beta1 or this coefficient is not different from 0. It is equal to 0. কথা কনক্লুশনটা বুঝতে পারছেন, যে স্ট্যাটিস্টিক্যাল সিগনিফিকেন্স বলতে ওরা মেইন করে হচ্ছে স্ট্যাটিস্টিক্যালি ডিফারেন্ট ফ্রম 0। তো ডিফারেন্ট ফ্রম 0 কোথায় বলা আছে? বলা আছে হচ্ছে অল্টারনেটিভ হাইপোথিসিসে। তার মানে যে কোনো একটা কোএফিশিয়েন্ট, whether it is beta1 or beta2 or beta3, whether these coefficients are statistically significant, it means they are statistically different from 0. Their value either minus or plus, but other than 0. 0 ছাড়া যে কোনো ভ্যালু হতে পারবে। তার মানে in that case I can conclude they are statistically significant. But if my null hypothesis has been accepted, মানে যদি b1 বা beta1 equal to 0 accepted হয়, then my conclusion is it is not significant. মানে হচ্ছে এটা significant না। তার মানে হচ্ছে statistically এটা 0 না। Sorry, statistically এটা 0, it's statistically it's not significant. It's not different from 0. So it's not different from 0. আমার অল্টারনেটিভ হাইপোথিসিসটা স্ট্যাটিস্টিক্যালি ডিফারেন্ট ফ্রম 0 হবে তখনই যখন আমার অল্টারনেটিভ হাইপোথিসিসটা অ্যাকসেপ্ট হবে। আর নাল হাইপোথিসিসটা যখন অ্যাকসেপ্টেড হবে তখন আমাকে কনক্লুশন ড্র করতে হবে যে দিস কোএফিশিয়েন্ট beta1 is not statistically significant. Is not statistically significant. That means it's equal to 0. Is that clear to everyone up to this portion of calculation?
Yes, sir.
Yes, sir.
Okay. Number F, last one. আচ্ছা, F এ বলেছে test at 5% level of significance. All partial slope coefficients are equal to 0. All partial slope coefficient are equal to 0. আপনাকে একটা null hypothesis ধরতে বলেছে যে all partial slope coefficient are equal to 0. And your alternative hypothesis is beta2 not is equals to 3 not is equals to 0. So beta2 and beta3 not is equals to 0. এবং এটা বলেছে আপনাকে একদম স্পেসিফিক্যালি বলে দিয়েছে যে টেস্ট এট 5% লেভেল অফ সিগনিফিকেন্স অল পার্শিয়াল স্লোপ কোএফিশিয়েন্ট। পার্শিয়াল শব্দটা বলা হচ্ছে বিকজ when we are dealing with beta2 holding the impact of the other slope coefficient constant, when we are dealing with the beta3 holding the impact of the other slope coefficient remain constant. মানে একটা নিয়ে যখন কথা বলবেন, b3 নিয়ে যখন কথা বলবেন, তখন b2 এবং b1 এর ইম্প্যাক্টটা কনস্ট্যান্ট ধরা হয়। আবার B2 নিয়ে যখন আপনি কথা বলবেন তখন B3 এবং B1 এর ইম্প্যাক্ট নিয়ে আপনার কোনো ধরনের ইস্যু অ্যারেজ করতে পারবে না, ওই দুইটার ইম্প্যাক্ট হচ্ছে কনস্ট্যান্ট হিসাবে থাকবে। তো এই জন্য পার্শিয়াল শব্দটা বলা হচ্ছে। দ্য ওয়ার্ড পার্শিয়াল ইজ গিভেন বিকজ ইউ আর ডিলিং উইথ অনলি ওয়ান সিঙ্গেল স্লোপ কোফিশিয়েন্ট, ইদার ইট ইজ β2 or β3 or β1। তো যখন যেটা নিয়ে কথা বলবেন, when you are dealing with only β2, it means you are assuming the impact of other coefficients will remain constant. Okay, fine. So after that, when you are just assume that H0 is this, H1 is this, you are dealing with the hypothesis test, which is followed by F test. Here you have been also asked to form the ANOVA table. So ANOVA table has been constructed with the calculation of the F test, or with the calculation of the F test for hypothesis test. And you will have to remember that F test or Fisher's test will be used to test the overall significance of regression model. ANOVA table, which has been constructed on the basis of the F test, and this F test or Fisher test is actually estimating the overall significance of the regression model. আমরা এতক্ষণ ধরে যে একটু আগে যে পার্ট ডিতে যেটা ক্যালকুলেট করলাম, বা পার্ট ডিতে আমরা যে স্ট্যাটিস্টিক্যাল টেস্টগুলো করলাম, ইট ইজ অ্যাকচুয়ালি ইন্ডিভিজুয়াল স্ট্যাটিস্টিক্যাল টেস্ট। ইন্ডিভিজুয়াল টেস্ট বলতে আমরা মিন করছি individually whether β2, β3 or β1 are statistically significant or not, আমরা এটা টেস্ট করি হচ্ছে টি টেস্ট দিয়ে, ইন্ডিভিজুয়াল দিয়ে করছি আমরা, ইন্ডিভিজুয়াল ইম্প্যাক্টটা আমরা অ্যাসেস করছি। তার মানে মোর স্পেসিফিক্যালি আমাদের যদি এইটা হয় মডেল, এখানে B1 আছে, B2 আছে and B3 আছে। So when we are assessing whether there is any impact of the X2 on Y, or whether there is any impact of X3 on Y, we will assess their statistical significance considering their value of the slope coefficient B2 and B3. And we will do their statistical significance test using the t-test, and this t-test has been given to know the individual statistical significance, individually whether X2 is affecting on Y, or individually whether X3 is affecting on Y. That is what we will do considering the t-test. But when we are dealing with the F test, we are actually going to assume that whether X2 and X3 simultaneously or together have any impact on the dependent variable Y or not. X2 এবং X3 একসাথে একত্রে কোনো ইম্প্যাক্ট আছে কিনা Y এর উপরে, সেটা আমরা অ্যাসেস করি হচ্ছে F টেস্ট দিয়ে, যেটার নাম হচ্ছে ওভারঅল টেস্ট অফ সিগনিফিকেন্স বা টেস্ট অফ ওভারঅল সিগনিফিকেন্স। একই সাথে X2 এবং X3 বা একই সাথে X2 এবং X3 Y এর উপর কোনো ইম্প্যাক্ট আছে কিনা, simultaneously do they have any impact on the Y or not, we will assess it considering the hypothesis test followed by F test. তো F টেস্টটাকে আমরা এই জন্য বলি হচ্ছে টেস্ট অফ ওভারঅল সিগনিফিকেন্স অফ দি মডেল। সো রিগ্রেশন মডেলের ওভারঅল কোনো সিগনিফিকেন্স আছে কিনা, we will do it by considering the F test. তো F test করার সময় I will require two information. One is explain sum of a square divided by the degrees of freedom. Another one is total sum of a square divided by degrees of freedom. Okay, degrees of freedom. So this all information is already known to us. একটা হচ্ছে explain sum of a square divided by degrees of freedom, আর একটা হচ্ছে total sum of a square divided by degrees of freedom. এইভাবে আমরা F টেস্টটা করে থাকি। তো F টেস্টটা দুইভাবে করা যায়, এটা একটা প্রসেস বললাম, আরেকটা প্রসেস হচ্ছে আপনি আর স্কোয়ারের ভ্যালু দিয়েও করতে পারবেন। সরি, এখানে হচ্ছে RSS নট TSS, RSS ডিভাইডেড বাই ডিগ্রিজ অফ ফ্রিডম, এটা দিয়ে আপনি F টেস্ট করতে পারেন। অথবা F টেস্ট করার আরেকটা সিস্টেম হচ্ছে কনসিডারিং ইউর ক্যালকুলেশন দ্য আর্লিয়ার পার্ট, আপনি আগে যে পার্টে ক্যালকুলেশন গুলো করেছেন সেটা দিয়ে আপনি ইউজ করতে পারবেন যে আর স্কোয়ার ভ্যালু ইউজ করে, ইউজিং দ্য আর স্কোয়ার ভ্যালু the degrees of freedom will be followed by k minus 1 and 1 minus r square value divided by n minus k. এই ফর্মুলা দিয়েও করবেন, আবার এই ফর্মুলাটা দিয়েও করতে পারবেন। Any of the formula you can go for to calculate your calculate the value of your F test. Okay, যে কোনো ফর্মুলা দিয়ে আপনি এটা করতে পারবেন। আর যখনই আমি আবারও বলছি যে F test যখন করবেন, this will assess the overall significance of the regression model, and this overall significance of the regression model means whether all of your explanatory variable or independent variable have any joint significance or joint impact on your dependent variable or not. That would be assessed by the F test. তো F test যেটা আমি অ্যাসেস করে সেটা হচ্ছে ওভারঅল সিগনিফিকেন্স, অথবা এটাকে আমরা জয়েন্ট সিগনিফিকেন্সও বলি, joint significance of the model. Jointly or simultaneously all independent variables are affecting your dependent variable or not, that would be done by the F test. So F test has been calculated in two ways. One is the first one, ESS divided by degrees of freedom in the numerator portion, and in the denominator portion, RSS divided by degrees of freedom. Degrees of freedom means k minus 1 এখানে, আর এখানে হচ্ছে n minus k. Okay, or it can be also calculated by R square in the numerator portion divided by the corresponding degrees of freedom. In the denominator portion, 1 minus R square divided by n minus k. Okay, any of the approach you can go for to calculate the F test value. So তারপরে এটা calculate করার পর you will get a calculated value, and then in the F table, you know that F table is showing the one tail test because F value can never be negative. F tested value কখনো negative হয় না, so it is showing the one tail test actually. So here what you have to do is you will get back to your last part of the text where you are given the F table. So F table এর value গুলা দেওয়া আছে. So in the numerator portion your degrees of freedom is k minus 1, in the denominator portion it is n minus k. K minus 1 means we have 3k here, so 3 minus 1 equal to 2 here degrees of freedom, and n minus k means we have 15. K means total number of total number of coefficient including the intercept term. So 15 minus 3, that means 12 here. So in the numerator portion degrees of freedom is 2, and in the denominator portion degrees of freedom is 12. Okay, তো সেটা দিয়ে আপনি F টেবিলের যে ভ্যালু আছে সেই ভ্যালুটা যেটা বের করবেন, that is your tabulated value, and then compare with your calculated value and tabulated value. If your calculated value is fallen under this white area, you will have to accept the null hypothesis. If your calculated value is fallen under the significance area, level of significance area, which is 5%, if it is fallen at the significance area, then you'll have to reject your null hypothesis. Okay, your null hypothesis is B2 and B3 is simultaneously equal to 0, or overall B2 and B3 is equal to 0 means overall no explanatory variable have any impact on your dependent variable, or jointly your explanatory variable does not have any impact on your dependent variable. And when H1 is B2 not is equal to B3 not is equal to 0, it means the explanatory variables jointly have some impact on your dependent variable. 0 হলে কোনো ইম্প্যাক্ট নাই, আর নট ইকুয়াল টু 0 হলে ইম্প্যাক্ট আছে। এটা তো বুঝাই যাচ্ছে যে আমি যদি মডেলের দিকে তাকাই, আমার যদি x2 এবং x3 জয়েন্টলি কোনো ইম্প্যাক্ট থাকে y এর উপরে, B2 and B3 can never be equal to 0. যদি এটা 0 হয়ে যায়, B2 and B3 is equal to 0 হয়ে যায়, then x2 and x3 will be multiplied with 0, and this y is equal to only B1. So it means x2 and x3 jointly do not have any impact on the y. So is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, then in the following class I will show you how the ANOVA table will be constructed. এই পর্যন্ত আপনারা করে ফেলবেন, মানে আমি যতটুকু বললাম F test পর্যন্ত করে ফেলবেন। F test পর্যন্ত করার পরে I will show you how to construct the ANOVA table, and then there are some other problems to solve from this chapter. We will solve it in the following class. আচ্ছা, আরেকজন যেটা কোয়েরি করেছিলেন এটা আমি পরের ক্লাসে আমি আগে দেখে নেই, পরের ক্লাসে আমি আপনাকে আনসারটা দিব। ওকে, যে লাস্ট চ্যাপ্টার থেকে একটা কোয়েরি ছিল বোধহয়, সেটা আমি পরের ক্লাসে বলবো। So let me take your attendance now. আচ্ছা, আমরা হচ্ছে নেক্সট ক্লাসটা করব হচ্ছে বৃহস্পতিবার দিন, অর্থাৎ ফলোইং ডে অফ দ্য টুমরো at the same time. Okay, আচ্ছা, বেটার হয় আপনারা একটা কাজ করেন, সবাই আপনাদের আইডিটা শুধু আমাকে চ্যাট বক্সে দিয়ে দেন। আইডিটা লিখে চ্যাট বক্সে দিয়ে দেন, তাহলেই হবে। রোল কল করতে অনেক সময় লাগবে, বুঝতে পারছেন? যেহেতু আমাদের টাইম আজকে কমে গেছে, একটু পরে আবার মাগরিব দিয়ে দিবে যে আপনারা,
র্যান্ডমলি।
হ্যাঁ আপনারা আপনাদের আইডিটা চ্যাট বক্সে টাইপ করে দিয়ে দেন, তাহলেই হবে সবাই। বুঝতে পেরেছেন? যার যার আইডি আবার মানে আপনি আরেকজনের আইডি টাইপ করতে হবে, আপনার আইডি শুধুমাত্র আপনি করেন।
স্যার আইডি 91 এর নেটে প্রবলেম হইতেছে, আমি কি ওটা টাইপ করে দিব?
হ্যাঁ, কারো যদি জেনে থাকেন যে প্রবলেম হচ্ছে তাহলে টাইপ করে দেন।
আচ্ছা
স্যার যাদের
হ্যাঁ,
হয়েছে
যারা
চলে যাই।
করেছেন তারা লিভ করতে পারেন। দিয়েছেন সবাই? যারা অলরেডি দিয়েছেন লিভ করতে পারেন। ওকে, ডান সবার? হয়েছে সবার?
ইয়েস স্যার,
ওকে,
থ্যাংক ইউ স্যার। স্যার আসসালামু আলাইকুম স্যার।
তাহলে আমরা আগামী পরশুদিন বৃহস্পতিবার আবার মিট করছি একই টাইমে 3:45।
ইয়েস স্যার,
Yes, sir. Thank you, sir. Assalamu alaikum, sir.
আসসালামু আলাইকুম স্যার।